Okay, imagine this scenario for a second. You're responsible for keeping something absolutely critical running smoothly. Think like a global banking system,
Hmm.
maybe a huge hospital network, or, essential government
Right, the
services.
kind of stuff that absolutely cannot go down.
Exactly. Every single second of unplanned downtime isn't just about lost revenue, though that's huge. It could mean massive disruption, maybe even putting people at risk.
Hmm.
But at the same time, to stay ahead, to innovate, you need to bring in the latest tech, like AI.
The pressure is definitely on.
So that's the real puzzle, isn't it? How do you bring in that powerful innovation, that AI capability, without jeopardizing the stability, the bedrock reliability of your operations? How do you manage both?
It's a fundamental tension. Yeah, this balancing act between rock solid reliability and the push for, well, disruptive innovation. It's what keeps CTOs up at night, I think.
It really is. So today we're diving deep into IBM's latest answer to this very challenge. We're talking about the new IBM Power11 enterprise servers, which they just announced on July 8th, 2025.
A big announcement in the enterprise space.
Absolutely. And our mission today is really to unpack what makes this Power 11 potentially so significant. We'll be focusing especially on that promise they're making, zero downtime AI integration. We want to explore the features that could, well, genuinely change how big organizations manage their most vital systems.
Yeah, and to do that, we're digging into a really interesting article by Dashvinjit Kaur over on AI News. It's titled, IBM Power11 Targets Enterprise AI Adoption with Zero Downtime Architecture.
Right.
He gives a great perspective on IBM's strategy here, betting on this integrated approach rather than, the more fragmented way things are often done now.
Okay, so let's start right there with the core problem Power 11 is trying to solve. You mentioned this challenge, deploying AI without compromising that essential reliability. What does the current landscape look like that makes this so tricky?
Well, IBM's starting point is pretty stark. For these critical systems, businesses just cannot afford downtime, period.
Non-negotiable.
Exactly. The difficulty comes because right now, many organizations are juggling, a sort of patchwork quilt. You've got your traditional reliable servers for core apps, and then maybe separate specialized hardware for AI tasks.
Right, different
Different
silos.
silos, yeah. Each needing its own management, its own updates, often its own separate investment. IBM's argument, their big bet with Power 11, is that integrated solutions are the way forward, running AI right alongside your core apps on the same resilient platform. It's about simplifying things, fundamentally.
Okay, simplifying. And speaking of simplifying things for the user, maybe not the engineering, let's talk about this zero downtime claim. That sounds ambitious. How are they backing that up?
It is ambitious, definitely. The headline number they're touting is 99.9999% uptime. It's nines.
6 nines. What does that actually mean in like real world time?
It translates to less than 32 seconds of unplanned downtime per year.
Wow. Okay.
Oh,
Less than tell me 2 seconds.
yeah. It's an incredibly high standard. IBM is actually calling it the most resilient server in the history of the IBM Power Platform. So they're putting a lot behind that claim.
That's a bold statement. So 32 seconds unplanned. But what about the downtime we plan for? Maintenance, updates, patching. That still takes systems offline usually.
Well, that's the other key piece here. Power 11 introduces something they call zero planned downtime. The idea is that you can perform system maintenance, apply updates, do patching, all while the applications keep running.
So no more maintenance windows where everything grinds to a halt.
That's the goal, eliminating those traditional offline maintenance periods. Think about what that means for, say, banking transactions or accessing healthcare records. Continuous operation. It could fundamentally change how IT departments schedule their work.
That alone is a massive benefit. Huge.
Yeah.
Okay, but the other half of the promise is the AI integration. How does Power 11 make AI practical, make it work within these ultra-reliable systems?
Right. It's not just about keeping the lights on. It's about adding intelligence.
Mhm.
They're doing this with on-chip acceleration for AI inference.
Inference. Can you quickly clarify what that means in this context?
Sure. AI inference is basically using an already trained AI model to make predictions or decisions in real time. So think about analyzing transactions for fraud as they happen, or assisting with medical image analysis right away. It's the using the AI part, not the building the AI part.
Got it. And putting the acceleration on the main chip itself?
Yeah.
What's the advantage there?
Lower latency, mainly. The data doesn't have to travel as far, basically. And potentially better power efficiency compared to using separate off-chip accelerators for everything. It's about making those real-time AI decisions faster and more integrated.
And isn't there a dedicated chip coming to something more specialized?
Yes, exactly. They've announced the upcoming IBM Spire accelerator. It's a specialized chip designed specifically for those AI inference tasks, the heavy lifting of running the models. That's expected later this year, Q4 2025.
Okay, so specialized for inference.
Right. The big plus for organizations is being able to run these AI applications side by side with their traditional core workloads on the same box, essentially. No need for completely separate infrastructure, separate management headaches for the AI bits. It's about merging those worlds.
That sounds incredibly efficient. So beyond the AI and the uptime, what about just raw performance? How does Power 11 stack up against, say, older power systems or even the competition?
Yeah.
Because cost and performance per dollar always matter.
Oh, yeah, they're quoting some pretty significant numbers. Uh, Up to 55% better core performance compared to Power 9 systems.
55%, that's a big jump from 2 generations ago.
It really is.
Yeah.
And they're also saying up to 45% more capacity than Power 10, the immediately preceding generation. Think about what that means for consolidation. Fewer physical servers potentially, smaller data center footprint, handling bigger workloads. It changes the economics.
Definitely. And what about energy efficiency? That's a huge topic now, data center power consumption.
They're hitting that hard too. The claim is twice the performance per watt compared to comparable by 86 servers.
Twice the performance per watt.
Yeah.
Compared to standard by 86.
That's the claim, which, if it holds true in real-world deployments, is a massive deal for operational costs, for electricity bills, and for sustainability goals.
Absolutely.
And there's more granularity, too. They mention a new energy-efficient mode, which offers, they say, up to 28% better server efficiency compared to just running flat out in maximum performance mode. So it gives operators some choice, some ability to tune based on their needs.
Okay, so performance looks strong, efficiency claims are impressive, AI is integrated, but none of that matters if the system isn't secure, especially with threats like ransomware getting more sophisticated. What's the story on security and resilience?
Yeah, security is paramount. Power 11 features an integrated solution called the IBM Power CyberVault. This is specifically designed to fight ransomware.
CyberVault, how does it work?
It automatically creates, stores, and importantly tests immutable snapshots of your data. Immutable meaning they can't be changed or encrypted by ransomware.
Okay, snapshots are common, but the testing part sounds key. And how fast does it react?
That's the really impressive bit. They claim it can capture these snapshots within a minute of ransomware detection. So the idea is incredibly rapid protection and the ability to recover quickly, minimizing data loss from corruption or encryption. It's very proactive.
Within a minute, wow. And testing them means you know you have a good recovery point.
Precisely. It's not just hoping your backup works. It's
And-
verifying it continuously.
What about future threats? Things we aren't even fully dealing with yet, like quantum computing breaking current encryption.
They're addressing that too, looking ahead. Power 11 includes NIST-approved quantum-safe cryptography.
Quantum safe. What's the specific threat that addresses?
It's designed to protect against what are called harvest now, decrypt later attacks.
Harvest now, decrypt later.
Yeah, the idea is that attackers might steal encrypted data today, data they can't break with current computers. But they hold on to it, knowing that future quantum computers will be able to break today's standard encryption. So they harvest it now, planning to decrypt it later when the tech arrives. Quantum-safe crypto aims to make the data secure even against those future quantum threats.
Okay, that's some serious forward thinking on data protection. So putting this all together, the uptime, the AI, the performance, the security, who is this for? Who traditionally uses power systems? And how easy will it be for others to adopt this?
Well, historically, you see IBM Power heavily used in sectors like banking, finance, healthcare, large retail operations, government, basically places where reliability and high transaction volumes are absolutely critical.
The traditional stronghold.
Exactly. But Power 11 is being offered with flexibility. There are high-end, mid-range, and even entry-level server options. Plus, it's available in the cloud via IBM Power Virtual Server on IBM Cloud.
So potentially broader accessibility. What about fitting into the modern IT landscape, like cloud-native development, open source?
That's important too.
Yeah.
IBM is highlighting the integration with Red Hat OpenShift AI and more generally the open source ecosystem. That's pretty crucial for attracting developers and fitting into modern DevOps pipelines.
Makes sense. Are there any unknowns still? Things potential customers will be waiting to see?
Well, naturally, detailed pricing and the total cost of ownership figures haven't been fully disclosed yet, and those are always major factors in any enterprise purchase.
Always.
And of course, while the specs and claims are impressive, businesses will want to see independent validation, real-world benchmarks of the AI capabilities, and just how seamless that zero downtime feature operates under pressure.
Right. The proof is in the pudding, as they say. So when can organizations actually start using Power 11?
General availability is set for July 25, 2025, so very soon. The specialized Spire accelerator for AI is slated for Q4 2025. And they also mentioned bringing watsonx.data, their data lakehouse solution, to Power 11 by the end of 2025.
Okay, so the rollout is starting now and continuing through the year. It's clearly a major strategic move for IBM in a very competitive market.
Definitely. It's their play to consolidate that traditional strength and reliability with the absolute necessity of integrating AI all onto one platform, addressing that core tension we started with.
Right. So wrapping this up, what does this all mean for you, our listener?
Well, IBM's Power 11 seems to be a really significant attempt to build a future where those absolutely essential mission-critical systems can finally embrace AI fully without compromising the stability, that rock-solid reliability that businesses and, frankly, all of us depend on.
It's IBM trying to fuse the old requirements with the new demands of AI.
Exactly. And here's a final thought to leave you with. If systems like this can genuinely achieve zero planned downtime, if they can proactively defend against even future quantum-level cyber threats, how might that change things? Yeah, think about it. How does that reshape not just corporate IT, but maybe the services you rely on every day? Does it accelerate innovation? Does it change how we think about trust in this increasingly complex, data-driven, AI-powered world? Something to ponder.